Hey everyone, this is Dr. Walker. This is video 502 called Scalar Product. The scalar product is also called a dot product. The scalar product is a type of product between two vectors. The thing about this type of product is, as the name implies, it gives us a scalar. So when you take the scalar product or the dot product of two vectors, you get AB, which is the magnitude of A and B, times cosine of theta, where theta is the angle between A and B. If you look at this picture here that has a vector A and a vector B, and you'll notice that theta is the angle between them, you'll notice that B cosine theta is the projection of B here, right? The projection of B along A. Right, the part of B that is in the same direction as A. So you're basically multiplying the projection of B onto A times A. So if you think of it that way, it's useful to think of the dot products as being how parallel are two vectors. If the dot product is high, then that means that these vectors are going to be very parallel to each other. And we'll see that in the next few slides as well. But I just wanted to already kind of hint to that the dot products tells us how parallel two vectors are. Let's look at the properties of the scalar product. So if two vectors are parallel, that means that the angle between them is 0. And we just said that the dot product A dot B is equal to AB cosine theta. Cosine of 0 is 1, so that gives us that the dot product of two parallel vectors is just the product of the magnitude of each vector. If vectors are anti-parallel, so that means that they're parallel but they're pointing in opposite directions. So vector A goes this way, vector B goes this way. Well, in this case, the angle between them is 180, so when you do cosine of 80 and you get -1, you get that the dot product of two anti-parallel vectors is going to be negative AB, where A and B are the magnitudes of each vector. And lastly, if you have orthogonal or perpendicular vectors, so vector A is this way and vector B is this way, well then the angle between them is 90 and cosine of 90 is 0. So the dot product of two perpendicular vectors is 0. So this is why I said that the dot product tells you how parallel vectors are. When they're parallel, you get the highest dot product possible, which is the magnitude of each vector multiplied by each other. If the vectors are perpendicular to each other, you get the lowest magnitude possible for the dot product. You get 0. So a few identities of unit vectors and using dot products. Well, we just said that parallel vectors have a dot product equal to 1. So if you dot two I vectors, which both point along the x direction, they're parallel to each other, right? Or if you dot two j vectors or two k vectors, because these vectors are parallel to each other, their dot product is equal to 1. If you have perpendicular vectors, such as I dot j, right? All the unit vectors are perpendicular to each other. Well, then the dot product of those vectors is going to be 0. So that's a little shortcut when we are going to be working with dot products, especially when we start talking about work. That is a really good application of dot product. When they're parallel unit vectors, the dot product is 1. When they're perpendicular unit vectors, the dot product is 0. The last thing I would like to go over is, well, how do we calculate the scalar product? We know it's AB cosine theta, So if we have the magnitude of each vector and the angle between them, then yes, we can find the dot product. But what if we're just given the vectors in unit vector notation? Then how do we calculate the scalar product? Well, the way that we calculate the scalar product is we add up all of the components separately. So we're going to take all of the x components and add them. Notice we don't follow this by I or j because the scalar product is a scalar. We don't want to end up with a vector for our answer. So we add up just the numbers, the x components, and then the y components of each vector here. We just add them up. And then the z components of each vector, we just add them up. And then we just sum up those three products to get the scalar product. We will do an example in the video that follows, but first, the last thing is that using this definition of the dot product, it also gives us a way to find the angle between vectors. So let's say we are trying to find the angle between two vectors. And we're given vectors A and B, then all we have to do is find the dot product of those two vectors and divide it by the product of the magnitudes, right? And this comes from just manipulating this equation to solve for cosine theta. And then, of course, you would take the inverse cosine of both sides to get theta by itself. Let's look at an example in the video that follows.